We'll quickly talk a little bit about reflections. Reflections give you a mirror image over a particular line. Now, in general, reflections are somewhat difficult to do algebraically, but there are three reflections that are very easy to do. There are reflections about the y-axis, the x-axis, and about the line y equals x. So we're going to briefly talk about what happens with those. So if we replace x by minus x in the formula, the graph turns out to be reflected about the y-axis. Okay, and of course, collectively, if we replace x by x and the graph stays the same, collectively at least, that's symmetric with respect to the y-axis. So here we've replaced x by minus x, and it reduces to the same thing. So notice points are being moved around. Like this point, negative 416, is mapped to the 416. The only point that's fixed is this particular set of points is the origin. But notice that negative 416 goes to 416, but 416 goes to negative 416, so they sort of switch places. And when the dust settles, they're collectively the same, so it's symmetric about the y-axis. Here's one that's not symmetric about the y-axis. Y equals x cubed. When you replace x by minus x, it reflects over the y-axis here. So the points in the first quadrant go to the second. The points in the second quadrant go to the first. Similarly, we can reflect over the x-axis by replacing y by minus y. So y equals x squared, put minus y equals x squared, which is equivalent to y equals the opposite of x squared. And notice what's happening here. Again, we're changing the sign of the y, not the x, the y. So x's are left alone from pre-image to image, but the y's change sign. And what that does is that takes this and just simply takes the stuff here and reflects this over. So the here was something wrong end of that. Let's see if I can flip this around. That goes. So points are just moved straight up and down. If I can get this to go straight up and down. So forget it. So points in the first quadrant are moved down to the fourth, and points in the second are moved straight down to the third quadrant, and the origin is left alone there. In general, points on the x-axis are left alone. And so this one here, we're changing the sign on y here, and it flips this way. Now, we can also reflect over the line y equals x, and the way to do that is you switch x and y in the formula. And the relationship between these two relations is they're called inverse relations to each other, because in a sense they undo each other. They're opposites. Y equals x squared and y equals the square root of x are kind of opposites. Okay, so you take y equals x squared and switch x and y, you get x equals y squared. Now to solve that for y, it takes two equations, y equals square root of x or y equals the opposite of square root of x. You need both of those. So notice what we're doing here is from pre-image to image, we're just taking the x and y and swapping them. And what this does graphically is it reflects over the line y equals x. Okay? And so this line connecting pre-image and image point is perpendicularly bisected by the line y equals x. Here's another example, y equals x cubed. The inverse is y equals x cubed. Being an odd root, we can solve that for y in one single equation, y equals the cube root of x, or y equals x to the 1/3 power, and we get the relation there, which they're both functions here. Over here they're not. Defining parameters, notice that a general reflection requires that we specify a mirror line. We then just simply move pre-image point to the same distance on the other side of the line so that the line connecting the pre-image and image point is perpendicularly bisected by the mirror line. So general reflections require more work than we're going to go into in this course. We're only considering these three specific reflections about the x-axis, y-axis, and the line y equals x, which have very nice, easy formula manipulations to get us there. The image of a figure under a reflection is congruent to the original image. It's the same size and shape, although oriented differently. All distances and angles in the image are the same as the corresponding measurements in the pre-image, and so it's the same size and shape as the original, but it has been reoriented with this reflection. Points on the mirror line or axis of reflection, sometimes called, are fixed in the reflection. A figure that has line symmetry is its own mirror image, and we will examine many graphs that are symmetric with one of the three lines we're studying. Of course, any symmetry is a special property, and most relations do not have any symmetry at all, but some have special symmetries like reflective symmetry.